On to section 2.3 in inequalities. 2.2 dealt with adding and subtracting in order to isolate the variable. 2.3 deals with multiplying and dividing, and it is pretty straightforward for the majority of this section. However, there is one thing that we have to be cognizant of, and that's when it comes to negatives, and we'll deal with it when we see it. So we see what's happening to my variable. 8 is multiplying. The inverse of multiplying by 8 is dividing by 8. 7 is less than or equal to b. Again, I advise students to rewrite it with the variable first. So we read it as the solutions. The solutions are greater than or equal to 7. 0, 7. Since there's an equal sign, we're going to have a closed circle. The solutions are greater than, so numbers that are greater than are to the right on the number line. And we notice that when we had our variable second, our inequality was eating the variable. So when we rewrote it, the inequality is still eating the variable. That's how we know if we wrote it correctly. There you go. Yeah, so that's pretty straightforward. We have, again, what's happening to the variable. 7 is being multiplied. The inverse of multiplying 7 is dividing by 7. This gives us -2 is less than t. I don't flip any inequality. Just because I have a negative doesn't necessarily mean I flip it. I divided both sides by a +7, so I don't have to do anything to the inequality. So I do 0, I do -2. It doesn't have an equal sign, so it's going to be an open circle, not including the border. And then if I want to rewrite it, t is greater than -2. That helps me know which way I'm graphing. So this is an interesting thing. So at the moment, and this is where we have to understand why we flip the inequality sign. So notice my variable at the moment is being eaten by the inequality sign. And if I wanted to get that to be a +7, I would have to add 7a, which moves it across the inequality. So now my variable is positive, and then we get 0 over here. So now notice when I moved it across the inequality, it went from greater than to less than, and I had to get it to be positive. Moving anything across an equal sign or inequality will change its signs. So it went from -7a to +7a. And then if I move the 21 across, we get this statement. So notice this -21 moved across and became +21. This -7a moved across to make positive. And if I isolate it, I get a is less than 3. Now, if I just divided by -7, I would get a is greater than. No, a is not greater than. So we need to understand that when we divide by a negative on both sides of an inequality, it is like moving it across the inequality. So it is very important that we notice that we multiply or divide both sides by a negative. We must flip the inequality because it is just like we are moving it across like this. So this is the correct way to do it. So the idea or the key idea is when you multiply or divide both, has to be both sides of an inequality. by a negative number. Like in this case, we divided both sides by -7. You must flip the inequality sign. So notice we flipped the inequality from less than to greater than, and we ended up with the same thing. If you add, we're not multiplying or dividing. If we add it across, we don't have to flip the inequality sign because it flips it just by moving across. So you're physically moving it across. Here we are moving it by dividing by negative. So we have to flip the inequality to represent it. So here is 0, here is 3. It's going to be an open circle, and it's going to be to the left. So very important key idea. This is the reason oftentimes you're told and you don't know why, or it doesn't make any logical sense. So now you know why, or what is physically happening, or what you're representing when you do this. 6 goes into 18 3 times. We divided both sides by a negative number, so we must flip the inequality sign. It goes from greater than to less than u, and then we can graph. I'm not going to rewrite it because I'm getting good at graphing. I know that my solutions are going to be open circle, and it's going to be going to the greater than. We're going to divide both sides by -0. -0.3. Divide both sides by -0.3. I get j. I have to flip the inequality to a less than, and 3 goes into 3.9, 1.3, and a positive divided by a negative is negative. So I get j is less than -1.3. I have 0. I have -1.3. I have an open circle, and my solutions are going to be less than. Here, I'm not going to divide by -8. The inverse of multiplying by -8 is definitely dividing by -8, but I don't want to deal with this fraction in a fraction. So we know that multiplying has two inverses. You can also multiply by the reciprocal. So the reciprocal of -8 is -1/8. -1/8. That's really, I'm gonna erase this. I'm going to erase this. I'm going to move this over a little bit so I can show my work a little bit better. -1/8. So notice I took my time. I'm writing it clearly because I want to cancel. I don't want to multiply -1 times 4 and 8 times 7 and then reduce that fraction. I see that 4 in the numerator and 8 in the denominator have a common factor of 4. 4 goes into 4 once, 4 goes into 8 twice. I have a negative and a negative right here. That's going to make positive. So I have 1 times 1 over 14. So that leaves me with 1/14. I multiplied both sides by a negative. I have to remember to flip the inequality sign. So there are lots of things to keep track of on this problem. This is a really good problem to see if students are going to keep track of all of the noise and busy stuff. So 1/14 it is equal to, so I have a closed circle, and I'm going to go less than. Notice I am not 1/14 close to 0. I could write it as far as I want. I want my students to see the work. Here we go. P is being divided by 2. The inverse is multiplying by 2. I multiply both sides by +2, so I don't have to flip the inequality sign. Even though I got a negative number, we have to do it to both sides. Because if you multiply both sides, it flips both things across. That's our reasoning behind it. So P is greater than or equal to -6. That's a closed circle going to the right. Let's move this. This time we're going to multiply both sides by -2. So we do multiply both sides by -2. That leaves me with n. I have to flip the inequality sign. I have 0, -6, open circle, and n is greater than. So it's going to go to the right. Very similar problems. We keep doing somewhat of the same step. They look similar. We should notice that when we multiply both sides by a negative, we have to flip the inequality. It goes from greater than to less than. -9. We have 0, -9, open circle, and less than. These should get really good, really easy. You should see the simplicity of this. You should start seeing the pattern and how fast. -1/3, the reciprocal is -3. A negative times a negative is a positive. I have to flip the inequality because I multiply both sides by a negative, and we get C. So I have 0, I have 21. I'm going to close my circle because it's equal to, and I want to be less than. Yeah, these are good, really good problems that you want to show that you can be proficient at. I'm going to multiply both sides by 2. I don't need a calculator. I should be able to double 1.7 and get 3.4. I don't have to flip the inequality because I'm just multiply both sides by a +2. 3.4, close circle, and going less than. I have a fraction. I don't want to divide by 2.3, 2/3. I'm going to multiply by the reciprocal of 2/3, which is 3/2. 3/2. 2 doesn't go into 15, so I can't reduce it. I can't reduce 3 and 15. They're both in the numerator. They don't cancel. So 3 times 15 is 45 over 2 is greater than W. I don't have to flip the inequality. I multiply both sides by 3/2. And I can leave that. I'd leave that as an improper fraction. There's nothing wrong with that. It's easy to graph. I just put it there. It's open circle and less than. I don't have to write 22.5. That's just unnecessary. That's extra work that I'm not requiring you to do. 11 over 2 is multiplying. I'm going to multiply by the reciprocal. This time, the denominator does go into the numerator. 11 goes into 11 once. 11 goes into -22 -2 times. 2 times -2 is -4. Is less than or equal to h. I don't flip it because I look and see what did I do to both sides. 0, -4. I have an equal sign, so I'm going to close circle, and my solutions are greater than. Wow, lots of problems. 1 through 15. Yeah, good. It's good. It's good practice, especially the multiplying by reciprocal. You should see that. That should be very, very apparent. So I'm looking at my denominator and numerator. They have a common factor of 3. 3 goes into 3 once. 3 goes into -15, -5 times. I have -5 times -5, which is 25. I must flip the inequality sign, and I'm left with my variable. I flipped it because I multiplied both sides by a negative. 0, 25, open, and going to the right. Last one of these types of problems. Ooh, we have fractions and decimals. Woohoo! So reciprocal is -9/10. -9/10. Now I could divide, or I could change this to -9/10. Why would I do -9/10? Oh, sorry. Gentle, easy. Why would I change it? Why would I change this to a decimal? Well, because I can multiply 9 times 37. 9 times 37. Mr. Mac, isn't that 0.9 and 3.7? Yeah. But the numbers, the digits that we're multiplying are relatively simple. 63 and then 27 plus the 6 that I carried gives me 33. And now I have 2 decimal places. So 3.33, negative times a negative is a positive. I'm going to flip the inequality because I multiply both sides by a negative, and I get D. So no calculator needed. I know my answer is pretty good. 3.33, no rounding, no nothing, closed circle, and it's going less than. I could have converted this to negative 37 over 10 and multiplied it by negative 9/10. There's a number of ways of going about solving this. I took the easiest. I don't mind multiplying. I can multiply these relatively simply, and I'm good at the timesing. You are scanning tickets at a concert. You have determined that you are scanning 16 tickets each minute. How many minutes will it take for you to scan at least 136 tickets? So 16 times M. M represents the minutes. How many minutes? And that must be to scan at least. So I need to have more than or equal to 136. And so this is your scanning. You have determined how many minutes. So if I'm going to solve this, I'm going to write it like this. I'm going to divide both sides by 16. That leaves me with M is greater than or equal to. Oh, I don't know my 16 times tables. So I don't know. I'm going to do 6 times 8 is 48. That's 128. That's pretty close to 136. Or I could take it as a fraction. I could have reduced it and gotten 68 over 8, taking half of 136 and half of 16. And then I can reduce that to 34 over 4, and I can reduce that to 17 over 2. And then I can reduce that, and a little bit more confident that that's going to be 8 and 8 is 16, so 8.5 minutes. So how many minutes will it take for you? It'll take me 8.5 minutes. Oh, I forgot. At least 8.5 minutes. I will get to 136 scanned tickets, and then from that point on, I will have more than enough. I will have done more than that. In 17, solve the inequality. Use technology to verify your answer. Ooh, now that's interesting. Let's see what type of technology we're going to use. Let's multiply both sides by -3. We get -9 is, whoa, Mr. Mac, you almost forgot to flip the inequality sign. His t is less than -9. So if I had to use technology to verify your answer, I mean, would I use Desmos? I don't know how I would use technology. I mean, maybe. Let's try it out. Let's see what Desmos calculator. What was my starting problem? 3 is less than t over -3. Oh, I should probably do x. Let's do x. So we notice we are at -9, and then values still less than -9. T is less than -9. We notice the shading goes to the left, so that's at -9. So I guess that's how we could use technology. Interesting way. I don't know if that's the best way, but we'll see. Well, that'll work. I'll accept that. We are going to, I don't want to divide because I have a fraction here, so I'm going to multiply by the reciprocal, which is 1/3, and G is less than or equal to, the 3 doesn't cancel with the 2 in the numerator, so we get 2/15, and that would be our solution. If we wanted to put that in Desmos, oh, sorry, Desmos is already gone. Desmos, let's do it again. 3G, or we'll say 3x, is that less than or equal to? Less than or equal to 2/5. So let's look at that value. 0.13 repeating says that that's the answer, and we said 2/15. So on a calculator, also technology, 2 divided by 15 gives us 0.13 repeating. So are our values less than? Yeah, less than. Our solutions are less than that value. And I wouldn't write a decimal there. I would just leave it as a fraction. It's cleaner, nicer. Divide by 1.2, divide by 1.2, and V is greater than 1.2, so we can make 7.2 over 1.2. Well, that's going to be 72 over 12, and half of that is going to be 36 over 6, half of 72, half of 12, and now I see, oh, that equals 6, so V is greater than 6. We can, do I still have Desmos in there? Yeah, I do. So let's write a new equation and use technology. 1.2x is greater than 7.2, and we get values that are greater than 6, and that coincides with values, solutions are greater than 6. Nice, right? That makes sense. You see, a game room is in the shape of a rectangle. You have $850 to buy new carpet for the game room. The dimensions of the game room are 20 feet by 12 feet. Write and solve an inequality that represents the cost per square foot that you can pay for the new carpet. Inequality represents the cost per square foot that you can pay for the new carpet. Okay, well, the dimensions of the game room, so I'm doing this out. I'm not totally confident in this, but we're going to try it. We're going to start writing things. We're going to get concrete. So the cost per square foot. So square foot, that means I have to find the area, which is 12 times 20, which is, my area is 240 square feet, and then so I'm gonna right, I mean, my cost is going to be 850 divided by my 240, and this cost per square foot needs to be right less than or equal to that. So my cost is going to be less than or equal to 850 divided by 240, or we can start reducing that. Divide it by 10. 8 and 5 makes 13, 24. I mean, let's do a little calculator. 85 divided by 24. Yep, that's ugly. So $3.54. C must be less than, what do we say? My son is being very, very loud. 85 divided by 24. $3.54. $3.54 per square foot. So cost needs to be that. I mean, that's how I would do it. We'll see. Let's check the answer key. Let's check the answer key first before we do that. Nope, next page. No more than $3.54. Yes, it has to be less than or equal to. Yay. We love it when we get problems right. You run for 2.5 hours at a speed no faster than 8.2 miles per hour. You want to run a marathon, which is 26.2 miles, in less than 3 hours. If you continue to run at that same speed, will you reach your goal? So you run at a speed no faster. You want to run a marathon, which is in less than 3 hours. If you continue, okay, so we know that we ran for 2.5 hours at 8.2 miles per hour. So this is going to be our initial distance. Initial distance. Okay, so let's multiply that, double it, and then take half. So that's 16.4. Half is 4.1. So 20.3. Did I do that right? 20.3. Oh, 20.5. 20.5 miles, because I went 8.2, no more than that, plus my, if you continue to run, at the same speed. So I don't know how much more distance, or how much more time, let's do t, my remaining time, times 8.2. So these are miles plus the missing miles. Oh, well, that's 20 miles. That's 6 miles. I have less than 6 miles left. Yeah, I think this still will work. And it has to be, well, that's not going to be, no, technically. That would be an equal. Yeah, this is not good. So notice I just took a swing. This is remaining, but my t has to be less than 3 hours. So I ran for 2.5, and unless you want to run the marathon, which is in less than 3 hours, that's really fast. 3-hour marathon. I've already ran 2.5, so I've ran the 20. All right, so technically my time needs to be less than or equal to 0.5, and then how many more miles I have? I still have 26.2 minus 20.5. That's 5. That's 7. That's 5.7 miles left. So I have that many more miles left. So that's my distance that I have remaining. Can I? Oh, so, right, if, this is a weird one setting it up. I mean, I understand the problem. I understand all the info. I just don't know, run at that same speed. Will you reach your goal? So, so I have 0.5, and I'm going to run at, 8.2 miles per hour. So this would give me my speed and distance that I can cover. This distance needs to be, that distance needs to be less than or equal to, this is the mileage left, 5.7. Yeah, so, I don't see any variables, so. Why don't I have a variable? Oh, could I do, can I do, 3 minus t? Because 2.5, yeah, I think that might be an equation. Ooh, that'll be very interesting if that's the solution. It's going to be interesting. Let's look at 21. Let's look at problem number 21 solution. No, the distance you run in 3 hours is not more than 24.6, which is less than the distance required. Oh, so they want concrete. They don't want to write a problem. So we just need to know. Okay, let's go back to this. Let's go back to this info. So I have 5.7 miles left, and I have a half an hour left. So if I only have a half an hour left and I'm not running faster than 8.2 miles, so half of that's going to be 4.1. So the most I can run in that time is 4.1 miles, and I still have 5.7 left. This is my fastest, or the most distance. So this is not greater than this. So no, I will not run under 3 hours. That's some crazy running. All right, last one. The base of a triangle with a height of 7 units is represented by the formula B equals 2/7 A. Okay. The base of the triangle is less than 10 units. Describe the possible area of A of the triangle. So the base of the triangle is less than 10 units. So if we put the base at 10, if it's equal to 10, let's multiply by 7 over 2. Multiply by 7 over 2. We're going to cross cancel. So that would give me an area of 35, but that's at its maximum, is less than 10 units, so it's never going to be this, so area is always going to be less than, not less than or equal to 35. So describe the possible area will be less than 35 square units. Let's see if I got that one right. Less than. Let's go, baby! Yes. All right. So these are the solutions if you want to scroll through them. They are located online. Have a great day. Enjoy your Saturday. We're going to go watch some football.